fire, smoke, ash, and molten rock bursting from the Earth's surface. Volcanoes are some of the most powerful and awe-inspiring forces of nature. But have you ever wondered why they exist? Why, in some places, mountains breathe fire, while in others, the ground lies silent? Today we'll explore the story of volcanoes, how they form, why they erupt, and what they reveal about the restless heart of our planet. To understand volcanoes, we first need to understand the structure of our planet. The Earth is like a layered onion. At its center lies the core, a dense sphere of iron and nickel, some of it solid, some molten. Surrounding the core is the mantle, a thick layer of hot, semi-solid rock that slowly moves and flows over millions of years. And finally, on top, we have the crust, a thin, rigid shell of rock. But here's the key. The Earth's crust isn't one solid piece. It's broken into giant slabs called tectonic plates, and they're constantly moving, ever so slowly, like rafts floating on the softer mantle below. These tectonic plates are the architects of volcanoes. Where they move apart, collide, or slide beneath one another, the Earth's crust cracks open, creating pathways for molten rock or magma to rise. Let's take a closer look at the main types of plate boundaries that give birth to volcanoes. First, we have divergent boundaries, places where tectonic plates move away from each other. As they separate, magma from the mantle rises to fill the gap, solidifying to form new crust. Most of these volcanoes lie deep beneath the ocean, forming what's known as the mid-ocean ridge, a vast underwater mountain range that circles the globe. If you could drain the oceans, you'd see it, a continuous volcanic chain stretching for more than 65,000 kilometers. One famous example is Iceland, a land born from fire and ice. It sits right on the mid-Atlantic ridge where the Eurasian and North American plates are pulling apart, making it one of the most volcanically active places on Earth. The second type of volcanic birthplace is found where plates collide at what we call convergent boundaries. Here, one plate slides beneath another, sinking into the mantle. This process is known as subduction. As the descending plate melts, it creates pockets of magma that rise toward the surface, eventually forming volcanoes. This is how the Ring of Fire was born, a fiery horseshoe-shaped zone that encircles the Pacific Ocean. From Japan and Indonesia to Chile and Alaska, more than 75% of the world's active volcanoes are found here. Each eruption along the Ring of Fire reminds us of the immense power locked within our planet's crust. But not all volcanoes form at plate boundaries. Some erupt in the middle of tectonic plates, far from any collision or separation. How is that possible? The answer lies in hotspots, special places where plumes of superheated rock rise from deep within the mantle. When one of these plumes reaches the surface, it melts through the crust, creating a volcano. As the tectonic plate moves over the stationary hotspot, new volcanoes form in a chain. The Hawaiian Islands are a perfect example. Each island marks a different stage in the chain's evolution. The big island of Hawaii, with its active Kilauea volcano, sits directly above the hotspot, while older islands to the northwest have long gone dormant. Now that we know where volcanoes form, let's look inside one. Deep beneath a volcano lies a magma chamber, a reservoir of molten rock under immense pressure. When that pressure builds up, it forces magma upward through cracks called vents and conduits. When magma reaches the surface, it becomes lava. If the eruption is gentle, lava flows slowly, building broad, shield-shaped mountains like those in Hawaii. If it's violent, gas and ash explode outward, creating steep stratovolcanoes like Mount Fuji or Mount St. Helens. Volcanoes can also form smaller features like cinder cones or lava domes, depending on the composition of the magma and the gases trapped within. So what triggers an eruption? It begins when pressure builds inside the magma chamber. This pressure comes from dissolved gases, mostly water vapor, carbon dioxide, and sulfur dioxide. As magma rises, the pressure decreases, allowing gases to expand, just like bubbles in a soda can when it's opened. When the pressure becomes too great, the rock above can no longer contain it. The result, an eruption. Scientists study tiny earthquakes, ground swelling, and gas emissions to predict when a volcano might erupt. Although it's not always possible to know exactly when, modern monitoring systems have saved countless lives. Volcanoes are both destroyers and creators. Their eruptions can devastate landscapes, bury towns, and change the climate. The eruption of Mount Tambora in 1815 was so powerful that it caused a global year without a summer, leading to crop failures and famine. Yet, volcanoes also build new land and enrich the earth. Volcanic soil is some of the most fertile on the planet, nourishing crops around Mount Etna, Vesuvius, and beyond. Even entire islands like Hawaii and Iceland owe their existence to volcanic activity. Without volcanoes, Earth's continents and atmosphere would look very different. Volcanoes aren't just an earthly phenomenon, they exist across our solar system. Mars is home to Olympus Mons, the largest volcano known, nearly 3 times taller than Mount Everest. Venus has hundreds of volcanoes, and some may still be active today. Even Jupiter's moon Io is constantly erupting, driven by tidal forces that heat its interior. Volcanoes remind us that our planet is not unique, but part of a larger, dynamic universe. So why are there volcanoes? Because our planet is alive. Its surface shifts, cracks, and rebuilds itself, driven by heat from deep within. Volcanoes are the Earth's way of breathing, releasing energy from its fiery heart. They shape our landscapes, influence our climate, and sustain the cycle of creation and destruction that has defined our world for billions of years. The next time you see an image of glowing lava or hear about a distant eruption, remember, it's not just destruction you're witnessing, it's the heartbeat of a living planet. For thousands of years, people have lived in the shadow of volcanoes. From the rice terraces of Indonesia to the vineyards of Italy, communities have built their lives on volcanic soil. Why risk living near such danger? Because volcanoes give as much as they take. Their ash and lava, once weathered, create rich, fertile ground perfect for farming. Springs warmed by volcanic heat provide hot water and geothermal energy. And in some places, like Iceland, entire towns are powered by the warmth of the earth itself. It's a delicate balance between danger and reward. A reminder that humanity has always coexisted with the raw power of nature. But living with volcanoes comes at a price. History is filled with tragic reminders of their destructive force. In 79 AD, Mount Vesuvius erupted violently, burying the Roman cities of Pompeii and Herculaneum under ash and pumice. In 1883, Krakatoa exploded with such fury that it was heard over 3,000 kilometers away. Its ash darkened skies and lowered global temperatures for years. More recently, Mount St. Helens in 1980 and Mount Pinatubo in 1991 showed us that even in modern times, volcanoes can change the climate and disrupt lives on a massive scale. Yet, with every eruption, scientists learn more, helping us understand how to predict and prepare for the next one. Today, monitoring volcanoes is one of the most advanced fields in Earth science. Networks of satellites track subtle changes in the land's surface. Seismographs detect tiny earthquakes, tremors that often signal magma rising. Drones and thermal cameras peek inside craters too dangerous for humans to approach. These tools allow scientists to listen to a volcano's heartbeat. When the ground swells, gases increase, or heat patterns change, they know the Earth is preparing to move. Thanks to this technology, eruptions that once took the world by surprise can now be forecast days or even weeks in advance, giving people time to evacuate and survive. Volcanoes may be unpredictable, but they are not silent. Long before we understood plate tectonics, people tried to explain volcanoes through stories and myth. In Hawaii, eruptions were said to be the work of Pele, the fiery goddess of volcanoes. In Japan, Mount Fuji was believed to be a sacred gateway between worlds. And in ancient Greece, the blacksmith god Hephaestus forged weapons inside volcanic fires. Even today, volcanoes stir deep emotions, a mix of fear, respect, and wonder. They remind us that nature isn't something we control, but something we belong to. In every culture that has lived near them, volcanoes have inspired legends, rituals, and art, proof of the lasting bond between humanity and the planet we call home.